Welcome to another FC480 video. I'm your instructor Li Wan. So last video, I have shown you guys how to find a cumulative probability according to a z-score using the command nomsdisk, and how to find a z-score according to a cumulative probabilities using the command nomsif or nomsin, or whatever. I prefer to call it nomsinf. Because I think the inf part is short for inverse. I have linked up the video on the Moodle site just in case you forgot how to do things and you are too bored watching this video. So in this video, I'm going to show you how to use Excel command to find the z-score for a corresponding x value, and also how to use z-score to find its x value for any non-unit normal distributions. Non-unit normal distribution means when the mean is not 0 and the standard deviation is not 1. I have copy and paste this exercise for Khan Academy. So let's read the question prompt first. The grades on a chemistry midterm at Springer are normally distributed with mu equals to 67 and standard deviation sigma equal to 2, and William scored 66 on the exam. Please find the z-score for William's exam grade and round it to 2 decimal places. Instead of showing you the straightforward answer, I want to take a little bit detour so I can show you guys a little bit more. So first of all, instead of finding the z-score at one sitting, let's find its accumulative probability of William actually get less or equal to 66. And then using that accumulative probability, we'll find the z-score from there. Not because you can do it in one sitting, just because it's fun. The command that, like I said, every time that you use Excel to compute anything, you need to put down the equal sign first. The command that you'll be using will be disk. Click on it and you'll be able to see what the heck are you doing. So let's read the syntax. You will be able to require to put in x value, mean, standard deviation, whether it's cumulative or not. And let's look at the density function. It's exactly the normal density function that we're looking for. That's great, awesome. So we know that we're using the right command. X, which is the observation value, would be William's score, right? Which is 66. And the mean for the population will be 67. And the standard deviation is 2. Do we want a cumulative probability or not? Yes, we do. We simply need to type in true. Okay, this is true. And then we close the bracket. And then we get a probability. So what this means is that the area, the bell curve to the left of a vertical line, if there is a vertical line that says x equal to 66. And then we are going to use that to find our z-score. How do we do that? I'm going to use this accumulative probability to find my z-score. As we have just learned from the first video, this can be easily done with using a command called nomsinf. And then we'll put in the value that we have come up with, and we got minus 0.5, which is the correct answer. All right, so I want to show you a little bit more. Assuming that in this problem set, instead of knowing that William scored 66, assuming that we know William scored higher than 30.85% of the class. All right, let's assume that we know that. Instead, what would his score be? What would his score be? I'm gonna answer it right now. Well, we first of all put down the equal sign, nominf, which is a reverse nomdisk function that we just used. We know that the probability, which is cumulative, is 0.3085. We put that in. The mean is 67, the standard deviation being 2. And then we say yes. Voila! That's exactly William's test score. Alright, I hope you guys liked this video tutorial, and hopefully this will save you a lot of time in doing your homework and also solving real-world problem when you're asked to compute the chances of something happening where your underlying population distribution is a normal curve. And do remember there are several things that I mentioned in this two video that's going to be a very important concept. The height corresponds to a density. And for something that's more extreme to happen than your observation value, you sum up all the area under that curve. For something that's less extreme than your observation occurring will be the value that you sum up for all the area under the curve to the left of your observation. Okay, let me repeat myself one more time. So assume that you have a observation that's here. So what would be the chance of something that's less extreme than your observation happening? It would be the area under the curve to the left of your observation. All right, so assuming that you have an observation that's here, what would be the chances of getting that observation and something that's more extreme? It will be the area under the curve to the right of your observation. If you have questions, you know what to do, post it in the Q&A. I will see you guys in the next video. See ya!